All right, so we have been talking about rationals, which really just means fractions. Okay, so I'm gonna go ahead and just define that one more time. So whenever you hear the word rational in math, that really just means we're talking about a fraction where we have a numerator and a denominator. Okay, so today we're actually going to talk about solving rational equations. This is where we are going to get an answer. For example, x equals something, b equals something. We're solving for the variable. Okay, in fact, I'm going to put that on our paper, which means you should too. We are solving for a variable today, where in the past few times, everything up until this point, we've just been simplifying a rational, which means our answer is a fraction. Okay, but today we're going to get an actual answer for the variable. Okay, so for numbers 1 through 4, we're actually just going to practice simplifying rationals. Okay, so we're not solving anything yet. We don't see any equal signs here. We're just asked to factor and simplify. Okay, so first thing I'm going to look at is my numerator. Okay, I can factor my numerator, and that means I have to play the number game. I have 3 terms here. I need 2 numbers that multiply to my third term and add to that middle term. Okay, so I need 2 numbers that multiply to negative 70. Okay, well, I know it is divisible by 10, so I'm going to try 10 times 7. Okay, I want it to equal negative, and I want it to add to a positive 3. Well, I know that 10 minus 7 gives us that positive 3 that we're looking for. Okay, so that means I just found my 2 factors. Okay, so I can rewrite my numerator in factored form. b plus 10 and b minus 7 for negative 7. Okay, then I'm going to go ahead and put it over my denominator, which I cannot factor. That guy is already simplified. Okay, I am going to put parentheses around that piece, reminding you guys that it is a piece. Okay, now from this point, all we have to do is see what pieces are exactly the same on top and bottom. Well, I know b plus 10 are going to cancel out, which means my final answer is on top, b minus 7. When there's nothing left on the denominator, we don't have to write that 1 on the denominator. So we're just left with b minus 7. Beautiful. Okay, let's go ahead and look at number 2. Okay, so I can factor my numerator right here, and this time we only have 2 terms, which means we want to figure out what they have in common. Okay, well, first I look at the coefficients, 6 and 48. I know that I can divide both of those numbers by 6. Okay, so I can divide out 6 from both of those numbers. Okay, and now I look at my variables. 2k's there, 1k there. I can take the smaller amount, which is just 1k. So on the numerator, I factor out that 6k. Well, that would just leave me with 1k left from my first term. 48 divided by 6 is going to give me 8, so then that would be a positive 8. No k's left on that term. And there's my numerator when I factor it out. My denominator, k plus 8, I cannot factor. I'm just going to keep it as k plus 8 with the parentheses around it. And now all you have to say is what pieces can cancel out. K plus 8 and k plus 8. Okay, that just leaves me with 6k on my numerator. When that 1 is the only thing left on the denominator, we don't have to write it. Beautiful. Okay, well, let's go ahead and look at number 3. Same thing, we're just practicing simplifying these guys. Okay, so my numerator, 2 minus v, I cannot factor that guy. So I'm just gonna go ahead and keep that 2 minus v on top. But then my denominator, I can factor. So this means I'm looking at my third term, what 2 numbers multiply to 16 and are going to add to negative 10. Okay, 16. But add to negative 10. Okay, well, I know that 8 times 2 gives me 16. 8 plus 2 gives me positive 10. But if I want it to be negative 10, all I have to do is make both of these guys negative, because a negative times negative still gives me my positive. Negative 8 minus 2 more. Now I get my negative 10 I'm looking for. Okay, so that means my denominator now factors to v minus 8 and v minus 2. Okay, now here's the little tricky part, the little rule we have to remember in math. These guys, 2 minus v and v minus 2, they are almost exactly the same. They're just kind of like opposites of each other. So when this happens, they actually don't cancel out, meaning they don't reduce to a positive 1. They actually cancel out, but they turn into a negative 1. When they're almost the same, just opposites of each other, they actually simplify to a negative 1. So that means my final answer, we can just put that negative 1 on top for my numerator. Since my denominator, the only thing left is v minus 8. And there we go. Beautiful. Okay, one more where we're just practicing simplifying these rationals. Okay, my numerator, I can factor. I need two numbers that multiply to 20, add to 12. Okay, well, I know that 20, 2 times 10 gives me 20, and then 2 plus 10, easy peasy, gives me that 12 I'm looking for. Okay, so this means my numerator factors to a plus 2 for positive 2, a plus 10 for positive 10, and my denominator, I cannot factor, it's already simplified. I'm just going to put parentheses around it because that is an entire piece. Okay, now the pieces that are exactly the same on top and bottom, a plus 2 and a plus 2, which means I'm just left with a plus 10 for my numerator, nothing on my denominator, so I can just leave it as a plus 10. Beautiful. Okay, now we are getting into solving these guys, okay? So it's asking us to solve each equation. We're not going to talk about these extraneous solutions today, okay? So I'm actually just gonna cross that out. We don't care about extraneous solutions today. We're just solving for x here. We want to get a final answer of x equals something. Well, this is pretty intimidating, okay? But here's the thing we have to remember. When adding or subtracting, and now with solving an equation, the denominators have to be the same. So let's go ahead and put that note on our paper. Denominators must be the same in order to solve. Okay, so let's go ahead and take a look at number 5. Okay, so I need all of my denominators to be the same, which means they need all of the pieces. Okay, so here's what I'm going to do. My least common denominator, LCD. This is what I want all the denominators to be. Okay, well, my first one has an x. My second one has the same thing as my first one, an x. And then my third fraction has the x and the 2. So that means I need all of my pieces to have a 2 and an x, or 2x. It can also be written x2. Or let's go ahead and write it 2x. Yeah, that makes a little more sense. Okay, so I need all of my denominators to be 2x. Okay, so that means if both of the pieces are 2 and x, I need these I need to give the fractions the pieces that it's missing. So let's go ahead and look at my first fraction. This guy has the x, which means it needs the 2. We need to multiply the 2 to that first fraction. Second fraction, this guy has the x. Again, it needs the 2. It already has the x, it just needs the 2. My third fraction, guess what? It has all the pieces. It has the 2 and the x, so we don't need to multiply anything to that guy. Okay, so now let's go ahead and multiply this out. My first fraction, it was just 2 times 2. Well, that's just gonna be 4. Okay, then we have our equal sign. We're just multiplying the numerators here. And then I have 2 that has to be multiplied to that second numerator, 2x plus 2. Okay, and I didn't have to multiply anything to the last one, so plus 1. Okay, so here's the thing. You're like, okay, write that over our denominator. Now that we've made the numerators or the denominators the same, we've given them the pieces that they need, we don't care about the denominators anymore. It just becomes an equation that we can solve here. Okay, so from here, all I have to do is solve this out. Okay, so the first thing when solving an equation, we always see our parentheses. That means we must distribute. So 2 times 2x, well, that's just going to give me 4x. 2 times 2, that's 4. And then I just add that plus 1. That was not in the parentheses. Copy down, that equals 4. Okay, now it just becomes an equation. I'm going to go ahead and just add these two numbers together. Well, 4 plus 1 is just going to give me 5. So now I have 4x plus 5 equals 4. Okay, now I just continue to solve this guy out. The farthest from my x is this plus 5, so I have to do the opposite. Subtract 5 from both sides. So I get 4 minus 5 is negative 1 equals 4x. Okay, my last step is going to be the opposite of times by 4 is divide by 4, which means my final answer is negative 1/4. And there we go. Okay, so the first thing we had to do was just make all of our denominators the same, or just think, give the numerators the piece it needs to make the denominator the same. From there, you simply just solve the equation. Okay, so let's try that again. Let's look at number 6. Okay, so I need to find my least common denominator, LCD, which means make them all the same. Okay, well, the first guy has 1v. Second guy has 2 v's, so I know I need at least 2 v's, and then my third guy has a 2. So I need all the pieces to have at least 2 v's and a 2. All right, there's my LCD. Okay, let's look at our first fraction, 1 over v. It has 1v, which means it needs the second v and the 2, which means I need to multiply that guy 2v. Second fraction. It has the v squared piece. It needs the 2, so I'm going to multiply just the 2. Third guy has the 2v. It needs the second v, so just multiplied to v. Okay, I've made them all the same. I've given them the pieces that they need. I don't care about the denominators anymore. I just care about the numerators. 1 times 2v is just 2v. Equals 3 times 2 is 6. Minus 1 times v is just v. Okay, now this simply becomes an equation. Okay, the thing about this equation is that I have some v's on this side of my equal sign, 1v or negative 1v on that side. I need to move them all to the same side. I like moving the smallest amount, which means I'm going to add that v to this side. Well, 2v plus 1v now gives me 3v equals 6. Okay, and there's only one step I need to do here to solve. Opposite of times by 3 is divide by 3. That gives me my v all by itself. 6 divided by 3 is 2. Beautiful. Okay, well, let's keep going. I need all of my denominators to be the same, which means I need a least common denominator, an LCD. Okay, well, my first fraction has 1a. My second has 2, which means I need all of them to at least have 2. And then my third has 1. Okay, so they all need to at least have those 2 a's. So that's my least common denominator. So let's go ahead and multiply the pieces that they each need. My first fraction has 1a. It needs 2 a's, which means I need to multiply another a to that guy. My second fraction, look at that. He has everything he needs, so I actually don't need to multiply anything to that second fraction. Third guy has only 1a, which means I need to multiply another a to that numerator. Okay, once I've multiplied the pieces that they need to make them all the same, I'm just going to write out the equation. 4 times a is 4a equals, that numerator didn't have to change at all, so a plus 5. And 1 times a is just 1a. Okay, so a couple things we need to do here. I see some a's on this side that I'm actually just going to combine. 1a plus another 1a is going to give me 2a, so that's going to turn into 2a plus 5 on this side equals 4a on that side. Okay, well now I need to move all my a's to one side. I'm going to move the smallest amount, which is this 2, do the opposite, subtract 2a. Okay, so now I have 4a minus 2a is 2a. 2a equals 5. And my last step, opposite of times by 2 is divide by 2. Okay, we get a fraction here, but that's totally fine. A equals 5 halves. And there we go. We solved for our variable. Okay, let's keep practicing. Number 8, I need an LCD, which means I need all my denominators to be the same. My first one has an N, second has the same thing, so I don't need to put it again. Third one has a 5, so that means I need all of my denominators to have a 5 and an N to be the same. Okay, well, my first fraction has the N. It needs the 5, so multiply the 5 to that first fraction. Same thing, second fraction has the N, it needs the 5, so multiply the 5 to my second fraction. Third fraction has the 5, it needs the N, so multiply the N to my third fraction. Okay, now that I've multiplied the piece that it needs, I'm just going to write out the numerators. So 3 times 5 is going to give me 15, equals 1 times 5 is 5, plus 6 times N, 6N. Okay, this guy, all my N's are on one side. I don't have to combine any like terms here, so I can go ahead and just try and start getting my N all by itself. Do the opposite of a positive 5, subtract 5. 10 equals 6 times N. Okay, the opposite of times by 6 is divide by 6. That gives me my N all by itself. And this is a fraction that I can actually reduce, okay? Both of these numbers I can divide by 2 to make it a simplified fraction. So N equals 10 divided by 2 is 5. 6 divided by 2 is 3. 5/3. Love it. Okay, awesome. Let's go to number 9. Last 2 examples. All right, so the very first thing, remember, we need to find our LCD, our common denominator, make them all the same. Okay, so my first fraction has a squared. Okay, my second fraction has 2 and then 1 a's, so that means I need at least a 2 and at least 2 a's, so 2a squared. My third fraction, oh look at that, it already has all the pieces. It has the 2 and both a's. Beautiful, so there's my LCD. Okay, so let's multiply the piece that each fraction is missing. My first fraction has the a squared, it needs the 2, so multiply by 2. Second fraction has the 2 and 1 of the a's, which means it needs the second a, so multiply an a to that guy. Third fraction has everything it needs. I don't have to multiply anything to that fraction. Okay, so let's go ahead and multiply it out to find our new numerators and our equation. 1 times 2 is 2. Plus 1 times a is just 1a, or a, equals 1. And look at that. Don't even need my denominators. That right there is such a simple equation. Okay, only one thing I need to do to get a all by itself, and it's the opposite of this add 2, which is subtract 2 from both sides. 1 minus 2 is negative 1. And we are done with that one. Awesome. Last example. Okay, I need to find my LCD, least common denominator, make them all the same. First fraction has 3x squared. Second fraction has the x squared, okay, but we already accounted for the 3, so we're good with the x squared there. And then my third fraction, look at that, it already has everything it needs. Okay, so my least common denominator, if having all the pieces to make them all the same, will be 3x squared. So let's go ahead and multiply each piece that it needs. First fraction has everything it needs. Check. Don't have to multiply anything to that first fraction. Second fraction has the x squared, which means it needs the 3. So I'm going to have to take that whole little binomial and multiply it by 3. Third fraction has the 3x squared already. Don't have to multiply anything there. Okay, so now we just write out our numerators. 1 didn't have to change, so 1 equals. 3 has to multiply to x plus 1. And 5 did not have to change, so plus 5. Okay, whenever we're solving an equation and we see these parentheses, we must take care of those first. We got to distribute. So 3 times x, 3x, 3 times 1, 3. Bring down your 5. Bring down your equals 1. Awesome. Okay, looking at this side, there's a couple like terms that I'm going to combine right there just to make them one number. 3 plus 5 is 8. So now I have 3x plus 8 equals 1. Okay, don't need to move any x's. I can just start, whoops, sorry, just bumped the table, makes it really shaky. Okay, I can just start getting rid of things so that my x is all by itself. Okay, so I need to get rid of the 8 first. It's farthest from my x, so do the opposite. Subtract 8. Okay, well 1 minus 8 is going to give me negative 7 equals 3x is left. Okay, and then my last step, opposite of times by 3 is divide by 3. And this right here is a fraction, since we got rid of that. This right here is a fraction we can't reduce, so it is our final answer. X equals negative 7 thirds. And there